Imagine repairing a satellite in space, or exploring a distant planet full of rocky cliffs and steep craters. These tasks are dangerous for astronauts, but for robots, it's perfect. Technological innovation is not only huge, but crucial for the next steps in space exploration. Robots will lead to increasing mission efficiency and ensuring astronaut safety. This can be helped and supported by evidence such as NASA's robotic arms used for spacecraft repairs, which lead to mission efficiency, and autonomous rovers like Perseverance that explore challenging terrain. These innovations and advancements are important to minimizing human risk and enabling sustainable long-term presence in space, which determines the indispensable role of robotics in the future of space travel. Today, we'll explore how robotic arms repair spacecraft, how rovers like Perseverance conquer Mars, and why these advancements matter for sustainable space travel and the safety of Earth astronauts. First thing we are going to talk about is NASA's and Canada's famous Canadarm. This robotic arm is like a Swiss Army knife in space, used to capture satellites, repair spacecraft, and even help build the International Space Station. According to MDA Space, more recently, the newest generation of Canadarm, the Canadarm3, will establish the first space station orbiting the Moon. Gateway will support both human and robotic missions to the lunar surface, serve as a science laboratory, and act as a proving ground for exploration missions into deeper space. MDA continues by stating, the Canadarm3 robotic arm system will be a highly innovative, goal-driven autonomous system capable of maintaining itself and making decisions with minimal human intervention. It will conduct vital tasks on Gateway, including maintenance, assembly, and supporting astronauts during the spacewalks from a staggering distance of 400,000 kilometers from Earth. The Canadian Encyclopedia explains, during its 30-year career with NASA's Space Shuttle program, the robotic arm deployed, captured, and repaired satellites, positioned astronauts, maintained equipment, and moved cargo. This made satellites live longer, and because of tools like Canadarm, astronauts can focus on more complex tasks, while the arm handles repetitive or hazardous work. Next up, we have Perseverance, the autonomous rover on Mars. It navigates tough terrains like sand dunes and rocky plains all on its own. The Perseverance rover is searching for ancient life and collecting soil samples for a potential pickup mission to study them on Earth. Two science instruments mounted on the rover's robotic arm are used to search for signs of past life and determine where to collect samples by analyzing the chemical, mineral, physical, and organic characters of Martian rocks. On the rover's mast, two science instruments provide high-resolution imaging and three types of spectroscopies for categorizing rocks and soils from a distance, all help to determine which rock targets to explore up close. Perseverance used the same Sky Crane landing system as Curiosity, but with the ability to land it in more challenging terrain with two enhancements, making more rugged sites eligible as safe landing candidates. Rovers like Perseverance tackles tasks beyond human capability, venturing into hazardous terrains without risking human lives, and transmitting vital data back to Earth. By assigning these perilous missions to robots, not only expand the scope of exploration but also safeguard astronauts from extreme radiation, temperature fluctuations, and the effects of microgravity. NASA explains, to bring such a mission to the Red Planet from fiction to fact, NASA's Human Research Program has pinpointed 5 hazards that astronauts will encounter on their journeys. These include space radiation, isolation and confinement, distance from Earth, gravity or the lack of, and closed or hostile environments. The safety of astronauts is crucial, as they have many tasks to juggle. For this reason, robotics is important to the safety of our astronauts. NASA explains how they help astronauts deal with their chores to make sure they have time to do tasks only humans can do. Working autonomously or via remote control by astronauts, flight controllers, or researchers on the ground, the robots are designed to complete tasks such as taking inventory, documenting experiments conducted by astronauts with their built-in cameras, or working together to move cargo throughout the station. In addition, the system serves as a research platform that can be outfitted and programmed to carry out experiments in microgravity, helping us to learn more about how robotics can benefit astronauts in space. Robots are crucial for future missions like setting up habitats on the Moon or Mars. They can work tirelessly, laying the groundwork for humans to follow. With the Artemis program aiming to return humans back to the Moon, sustainability is needed. World Economic Forum writes, sustainability in space activities involve conducting them in an environmentally sound, economically viable, and socially responsible manner. As several countries have already outlined in their submissions to the UNCOPUOS Space Resources Working Group, key aspects include minimizing space debris, preventing contamination, and advancing technologies for responsible resource management. To conclude, in space exploration, every step is a leap forward for humanity. Robotic arms and autonomous rovers aren't just helpful tools, they're the key for safer, more efficient, and sustainable missions. Technological innovation plays a vital role in the future of space exploration, with robotics at the forefront of advancing mission efficiency and safeguarding astronauts' well-being. Evidence such as NASA's robotic arms for spacecraft repairs and autonomous rovers like Perseverance demonstrates how these innovations enable the exploration of challenging terrains and the execution of complex tasks. By minimizing human risk and supporting sustainable, long-term space missions, robotics proves to be an indispensable component in shaping the future of human space travel. As we push further into the cosmos, we need to keep supporting technological innovations in robotics. After all, this isn't science fiction. It's the future of exploration. It's reality.